All right, this video is going to look at 4 more examples working with the chain rule. And the first example that we have here is y equals sine pi of x. So we start off with a trig function. And if you notice the formulas that you see in your book, or if you have a formula sheet indicating the derivative of your trig function, you'll notice when we first started looking at the trig function, we had something like d dx of sine of x, and we simply said the derivative of your sine function is the cosine of x. Well, if you look at some of the formulas, they actually write d dx of sine of u, and keep in mind the sine of u, and a lot of books will have a formula sheet in the front or the back cover of your textbook, and they'll have different derivative formulas given to you, and they'll typically write them as the derivative of sine of u dx. So we're taking the derivative of the sine function with respect to the variable x, and u is not representing a variable, but u is a function of x. So you'll notice they'll say if we're taking the derivative of the sine function derivative would be the cosine of u, but then you'll notice that it is actually then multiplied by the derivative of u. So essentially here, this is using the chain rule property. So that's what we have here with the sine of pi x. We have the outside function, which is your sine function. So this would be y prime equals the derivative of the outside is the sine, so that would be the cosine, and we're going to leave everything else the same, so it's still the cosine of pi x. But then we're going to multiply this by the derivative of the inside function. So the inside function here is this u. So the inside function for us is the pi x. So the derivative of pi x would simply be pi. And that is the derivative for sine of pi x. And of course we could simplify this and put the pi in front. Usually, again, if you have something multiplied by a trig function, that will go in front of the trig function. So our derivative is pi cosine of pi x. Okay, so once again, we're taking the derivative of the outside. So this is really the chain rule, and this is the chain rule based on the derivative of the sine function. Derivative of sine is cosine, and then whatever the inside function is, this u. So the example we have, our u is the pi x. We have to take the derivative of the pi. So if we think of this as the pi x, if this is our u, then this here would be u prime. All right, another example. Secant x squared. Now, what is squared in this problem? Well, the part that is being squared is only the x. The secant function is not being squared. And if you recall, the formula for secant, the derivative for our secant function is d dx secant u. So the derivative is going to be secant u tangent u. Okay, so you first of all take the derivative outside function, which is the secant u tangent u, and then this is going to be multiplied by the derivative of the inside part, which is the u, which would simply be u prime. So in our example, again, we take the derivative of the secant function, which over here is going to be secant x squared tangent x squared, and then we have to take and multiply by the derivative of the inside function, which is the x squared. So all of this is multiplied by 2x. Whoops, and this would be the actual derivative. So secant x tangent x, or secant x squared tangent x squared, then the derivative of the inside would be 2x. So we could rewrite this, and again, you're normally going to put that 2x in front, so we'd have 2x times secant x squared tangent x squared. Okay, and the next example we have here is dealing with our cosine function. And once again, if we were looking at the derivative of cosine of u, and again, u is a function of x. So if we take the derivative of our cosine function, we know that's going to be a negative sine u, but then we have to multiply this by u prime, the derivative of the inside. So over here, the derivative of our outside function is looking at the derivative of cosine, which is a negative sine, and you write all of this down. We don't do anything with the inside yet. We just bring down the inside function 1 minus 2x quantity squared. Now we need to take the derivative of the inside function. Well, the inside function is 1 minus 2x squared. This is going to cause us to use the chain rule again, because here we need to take the derivative of the squared part. So that means we're going to multiply the 2 out front, so it's 2 times 1 minus 2x. And then this drops your exponent down to a 1. And then we need to take the derivative of the inside of that function, which is the 1 minus 2x. So the derivative of negative 2x would simply be a negative 2. So this one actually caused us to use the chain rule twice. We had to take the derivative first of the cosine. So this is the first step. Our second step is the square, and then the third step is the 1 minus 2x. So if you notice, when you take the derivative of the cosine, everything else stays the same. So the cosine is negative sine, 1 minus 2x squared, that all remains the same, multiplied by, again, 2 times 1 minus 2x. Okay, all we did here was drop the exponent down to a 1, and then you multiplied by the inside, 1 minus 2x, the derivative is negative 2. So from here, we could do a little bit of simplification. We could take the 2 and negative 2. That would give us a negative 4. So you have the 2, negative 2, and this negative sign. So that's a negative 4 times a negative. So we would have a positive 4. And then we have the 1 minus 2x. And that's going to be multiplied by the sine of 1 minus 2x squared. And that would be our derivative. Okay, the next example. Another trig function. We have g of x equals 5 cosine squared pi x. Now the question is, what is being squared in this example? Now you may find it beneficial to rewrite this problem, because notice the whole trig function is being squared. I prefer to rewrite this problem so we can visually see this better, even though we're going to use parentheses. I like to write this as cosine pi x. That quantity is squared. That's really what this means. So I'm going to start out by rewriting the original problem. So keep in mind, this squared, again, really means we're squaring this whole cosine pi x. So we want to take the cosine of pi x and square that quantity. So we can strictly kind of think of using the chain rule. And if we take the derivative, we know that the outside function here, the outermost function then, is the square. So we're going to take the exponent, and we can multiply that out front. Again, the 5 is just a multiplier, so 2 times 5, we would end up with 10. And everything else remains the same, cosine pi x. And we decrease the exponent, so that becomes a 1. Now we need to multiply by the derivative of the inside. Well, that would be the cosine pi x. So we need to take first the derivative of cosine, which would be a negative sine pi x. And then we need to take the derivative of the inside of that, which is pi x, which would simply be pi. So once again here we had to use the chain rule a couple of times. So again, think of this as working from the outside in. So the exponent, the trig function cosine, and then the pi x. And from here we can do some simplification. We have the pi and the 10 and the negative sign. So we could make this a negative 10 pi multiplied by the cosine of pi x. And we already moved the negative out front, so then we just have sine pi x. And that's really a good place to actually stop. But once again, sometimes with the quizzes and the multiple choice, they like to do some crazy cancellations. So if we look here closely, in your book with some of your trig identities, there's something called the double angle formulas. And we have a double angle formula that we can use. And the one that I want to look at is the sine of u, the sine of 2u is equal to 2 sine u cosine u. And I'll show you in a minute how we're going to use this double angle formula. Well, if you look at our problem here, we have sine u cosine u, so we have the cosine pi x, the sine pi x. Do we have the 2? Well, we have a negative 10 here. If we take and split that up, we know that we can factor 10. That's the same thing as 2 times 5. So if I split that up, we could write negative 5 pi, and then we would have 2 times the cosine pi x sine of pi x. And now we have this 2 cosine pi x sine of pi x, which all of that's going to be equal to the sine of 2u. So in the place of the 2 cosine pi x sine pi x, we can substitute in the sine of 2u. So in our case, that would be the sine of 2 times u. Well, the u in this case is our angle pi x, so it's 2 times pi x. So we could, the advantage here of simplifying this using this double angle formula is we eliminate one of our trig functions. We're able to write the derivative strictly in terms of our sine function. So if you're ever working an example and you're checking your answer in the back of the book, or if you're going through the practice problems or a quiz in Blackboard, then if you stopped, for example, up here, I mean, this is an okay place to stop. If you had negative 10 pi cosine pi x, sine of pi x, this answer is really a perfectly good answer. But if you're looking at a multiple choice quiz or problem, then this answer may not be there. And if you notice that all of the answers seem to have one trig function, that's when you may want to look at some type of identity. And in this case, the double angle formula was one that we could use here to rewrite this. And the clue that we use the double angle formula is that if you look at the trig function, we're going from cosine pi x. Now the answer is sine of 2 pi x. So the angle went from pi x to 2 pi x. So if you ever see that happen with the multiple choice answers, you may realize then that they may have used some type of a double angle formula. All right, so once again, keep in mind with the chain rule, you're going to work from the outside to the inside. And once again, I want to kind of emphasize this problem here, secant x squared. What is squared? The x is the part that is only squared. And if you compare that to the example down here, it's only the 1 minus 2x that's squared. But this example, because of the location of the 2, we're squaring the entire trig function. So you may want to rewrite this. So be careful with where the exponent is with your trig functions so that you can apply the chain rule properly.